How many of you are using Nightly here? So who's annoyed by the message once in a while that you get about you need to restart Nightly to continue using it? Nobody is annoyed. Oh shit, you're working for nothing. And so Alex is going to talk about that.
Yeah.
And so please sit. Remember, sit in the middle so people that come late can sit. Thank you very much. Oh, one last thing for the newcomers. We exit by the door that are downstairs. There are stickers on the tables here, here, and there. Please feel free to take them.
Hello, welcome to this talk. So I'm Alexandre. I have been working for Mozilla for more than 11 years now. And I'm here to present you something we called ForkServer. There is not my name on the slide because it has been a work not just done by me, but it also involved Thinkerly, Jet Davis, Nickel Hazel, and other people. So this is what Ludovic was talking about. How many people have been annoyed by that on their daily basis? It's mostly people under Linux, often on release, and let's explain why you see this. So the reason is that when we create a new process in Firefox, we have to read from disk. And whatever is on disk may have changed because your package manager applied an update. And so when we start the process, the child process that you need to view a website because you just opened the tab, then we have the child that is going to communicate with the parent process over IPC. And the first thing they are going to do is to verify the version they are talking about of the IPC protocol. Because if we are not using the same version, we are going to run into very weird issues that we had in the past, that were triggering super complicated bugs, that were wasting our time. So we decided to say if the version on disk does not match the version in memory between the parent and the child, then we stop everything and we annoy people. Because it's much fun for you to be annoyed than for us to be annoyed. That's the main motivation for the user-facing value of ForkServer. So first I will try to explain to you how we got into the situation with so much processes and why you run into that issue so often. Then we will explain a little bit in detail, but not too much, what is ForkServer, and have a look at the improvements outside of this dialogue, which should not come anymore. Let's do a little bit of history. A long time ago, the web was very simple. You had no audio, you had no video, you had computers with only one processor. The security was not so much of a big issue. The attack surface was much simpler. So the original design of a browser was a single process doing everything, doing the UI, doing the rendering of the web pages, doing the disk access, everything. And there was no good reason to split that into many processes because you had no CPU with enough processes to take advantage of it. Then a few years later, we introduced audio, we introduced video, and we did that, for example, using Flash, using NP API, which some of you might remember. And those were very complex pieces of software running within the process. So adding a lot of attack surface to the process, adding a lot of stability issues. So there was a good incentive to have a separate process for them. Because, for example, if Flash was behaving badly, we could kill it and restart it without having the whole browser to crash. So it was convenient for a user, and it was convenient for us. Less bugs that we would be blamed about. And the story continues a little bit over. We had GMP, which introduced some video codecs, and at some point the web became a little bit more complicated. We started to have to isolate stuff, and with more complexity, we introduced even more processes, like GPU, content, web extension. And as of today, everything involved is a process type in Firefox. So it means that you have around 10 process types that you can have on your computer. If you go into About Processes, you will see all of them. And for example, content processes can be instantiated for each tab on the browser. So each time you load a new website, you have a new process. It's more or less that. We have processes to manage access to the GPU, to take care of the video codecs, to perform audio and video decoding, to perform network access. And one of the main reasons we have that way to put things into different processes is security mostly, because we can perform sandboxing at the process level. On Linux, we perform sandboxing using seccomp, so it means that we are filtering system calls. And one very simple example is that content process does not have access to the file system. It does do a broker request to the parent process that can verify the file system access. So it means that we can control even more tightly security. We can forbid accessing some stuff for security purposes. We also use that for fingerprinting process focus. And recently we also introduced a new kind of process, utility process, that has the unique property to allow us to sandbox even more simply things. Because in the past, adding a new type of process was a little bit complicated. And we wanted to be able to sandbox a little bit more, especially, for example, audio decoding that was in the past living within the RDD process. So it means that we had to share the same sandbox between video decoders and audio decoders. And video decoders may require hardware access to a specific area of, for example, your GPU to perform audio decoding. And doing that often means that you have to open holes in the sandbox. And the sandbox, you want it to be as tight as possible. And the only way to sandbox differently is to have different kind of process. Let's just explain a little bit how we create a process. So for those of you who are a little bit used to that on Linux, you do clone and fork, and then you do exec. And exec is a good thing because it reloads everything from scratch, which is also a bad thing because it reloads everything from scratch. So everything we did in one process, we have to redo every time, and we lose all the nice things that we have on fork, like copy and write, which means that when you fork a process, you should be able to share memory that has not been modified by the child. And we cannot do that anymore. So each time we create a new process, it has a cost in CPU time and in memory. And as you saw now, we have a lot of processes in Firefox. And this is why we have ForkServer. So how do we create a new process with ForkServer? We ask another process. On Chrome, they already have Zigoti. On Firefox OS, a long time ago, we had a process called Nuwa. And the strategy is very simple. We start that process, we get it as far as we can in the startup process, and we will fork from that point later. So this way it's faster, we don't have to redo some of the initialization, and we can share more memory between processes. The risk is that now we don't have exec, so we may get into a state where we are sharing stuff that we don't want to share, like for example some random generators, which is not a good thing. Nuwa was one of the solutions we had on Firefox OS. It was very complicated. It completely started content processes, so the ones that we use to render web pages, and it froze them, and it did a lot of magic to be able to unfroze them and put them back into a state where it can be used as a new process. And it was very efficient, but it was also super fragile, and I have been myself the victim of a nasty regression, and I just added a test for Firefox OS, and we had a very bad execution time regression, and people blamed me when it was in fact a regression on Nuwa. With ForkServer, we have decided to go with a more simple design. We do not start a whole content process. We just start a very minimal process, but that is not minimal enough to share enough of data. We do communication over socket to perform the call to, to say, hey, I want a new process. And we do not start JS. And that's already triggering a bit of challenges, like we had to deal with chain malloc states. If we don't do that, we completely regressed web content performances. And I had a little bit of fun with PGO and PIDs. Basically, when we landed half of July, we got backed out because we have completely destroyed performances because we just broke PGO, but that's fine. And why is it fine? Because we have been able to relent. And now it is enabled by default on Linux, unlikely since end of October. There is still some work to perform to be able to enable that on all of the channels. But as much as I know, there have been nobody complaining about huge regression, which is nice. So if you are using nightly on Linux, please have a look. And maybe we have missed some issues, and please report them so that we can fix it. Because this is the wins that we have. Oh, yeah. So on those two charts, the first one is the memory usage of a content process. You don't see the figures, but the stack of points on the upper side is around 15 megabytes. That's before we enabled ForkServer. And when we enabled it, we go to 7.5 megabytes about. So you can also see the times we enabled and got backed out. So 50% improvement. And here we have a metric that we use to see the startup time of a process. So we went from around 60 milliseconds to around 52 milliseconds. So 35% improvement, that's not bad. And I guess that's
Merci.
all. If you have questions.
Yes. So any questions? And I guess we don't have questions. Thank you, Alexandre.